Welcome back to the 10th video. The last video? Maybe. This is to go through and look at the project, talk about some things in the two different projects, which is really just one project done with hierarchical instance static meshes, or ISMs, for HLODs, batching it, versus using the merged mesh method. And we'll show some of the issues with that I found that should be considered when you're picking how you're going to use, or if you're going to use, the HLOD system, world partition, streaming, etc. This is me, GameDevMicah. I'm on Twitter as GameDevMicah. I'm on Discord as GameDevMicah. You can hit me up on email, GameDevMicah@gmail. And of course, what's the other stuff? LinkedIn, Micah Berningshausen. That's me too. I'm a UE5 game developer working on an instruction game called Tear Up. It's also called Speed Up, which is the bus-based version of Destruction in UE5. And I'm doing some UEFN, or Fortnite optimizations. In these two levels, I've set up the level itself, so the base geometry that you would be able to build on or walk on, but not destroy. And I wanted to talk about how I think this is optimized using ISMs and HISMs and some funky tricks I did to instance things or make them render on the GPU efficiently, automatically, without impacting the traditional Fortnite building method of putting things and actors in place. I'd like to put these files up for download so you can grab the projects, but I'm using GitHub and they limit to about 25 megs a project, and I got like 200 megs worth of project to upload these things. So I've been playing around back and forth and splitting up zip files for the last couple hours. I'm just going to talk about this. If you need these project files, reach out to me. I guess that's part of the consulting. I'll send you the files. I will be uploading the PDF that we reviewed in the last 10 videos. That PDF, so you can convert it to your own language if you'd like, or just have it to review. It's going to be exactly the one we went over in those prior videos. I'll have some additional stuff down below just for reference about benchmarking and so on, but it's all just my meeting notes that are open for you to interpolate and get a hold of me and ask me to talk about. Help really accelerate our conversation or your buildings. I do not work for Epic. This is not condoned by Epic. I have not been through any of their education classes. I am not an Epic certified trainer. There are people like that. There's not a whole bunch of them that I've seen. There may be 4 or 5. Ian's one over at Cleverlike. Check out those guys. A lot of great people that are putting up videos on YouTube as well to try and do optimization for this stuff. My take on all this is get advice, get details, go out, try it yourself, figure out what works for you. I'm trying to put forward the best stuff I've found, but I am not a millionaire off of Fortnite Island, so I have not published any. I just play around in the editor. And so I'm looking at methods from UE5 that can be used in UEFN, but it doesn't mean that they have to be used. So the big thing that they focused on at Epic Fest or Unreal Fest in Seattle was profile, which means look at the different things you can look at, your project size, the frame rates on low-end devices like a Switch. Spend $99, go on eBay and get yourself a Switch at Lite and test out your level on it. You don't even have to talk to Nintendo. It's great. All right, what's been sitting on the screen here is the actual folder or project for the size that I want to show you. The left one here at about 69 megs on disk, or 69 megs, but about 100 megs on disk, that is using ISMs and not merged mesh HLOD. So no new meshes are created in this project to do the world streaming. It's only using instancing of custom meshes to do it. And then on the right here, this is using just a partial merged mesh HLOD, excluding some things, because there's a lot of issues here. I think one of them is if you don't have a ground included in your HLODs, you're going to have a whole bunch of individual meshes, which from my experience, freaks the HLOD out on trying to do a merged mesh for a cell size. So you may want to make sure you can always have it unified with a ground mesh, because I didn't. It went up to 2 gigs just for the HLODs. Must have hit a problem in the loop and only could do so much, because it's much smaller when I got rid of trees and rocks from being used in the merge mesh. By removing them, it went down to a more manageable size, under 200 megs here. So using ISMs, the actual file on disk is 100 megs bigger on the project we're going to look at because of the new created HLOD merged meshes used when you're using a merged mesh method. And so we're going to go look at what the merged I have my tongue's paralyzed, all right? So from birth. I won't tell you more than that, but yeah, I struggle to speak. I'm trying. So merged mesh HLODs creates a new mesh, a new material. That in this level we're going to go into, it takes up extra 100 megs on disk, so it will definitely add more to your package size. And we'll look at how much it adds. Let's see here. So this is the level that we're going to be looking at today, the practical example. It's a red, blue, green, and orange setup in just a little map, all right? So this is what it is. It's that simple. I don't have any device work done here. I don't even have doors in here. All I have in here is these lockers or vending machines. I haven't even configured them. I was just doing that to see when and if devices stream out. The last time I was in here, about 2 months ago, devices didn't stream out. They never left. Now, in the current update, I do see these things streaming out a little bit, so that's kind of cool. But anyway, I don't do much with devices right now, so keep that in mind. Because devices and verse, that can sync your project way more than the level can, or the level can sync your project more than devices can. It depends on what you have going on, what density, what's going on in your world. Is it a trim down? This would be like, I would say like a combat arena would be this. There's no real fun stuff going on to stop you or interact with. But if you have a whole bunch of movement in your world, a bunch of devices, trigger points and stuff like that, any of those things looping, especially if there are a lot of those things looping, calling back on themselves without player interaction, that's the type of stuff that can start to bog the server and bog your gameplay as well. And storing data, if for some reason you're like storing where players are, some data from the world every frame, and never getting rid of that or looping it or ending the amount of data stored, it'd be like a memory leak. It would be storing data forever, adding. So, all right, so what do we have going on here? I built my buildings, like this building here, out of typical, and in this merged mesh example, out of just typical Fortnite stack. Let's see, where can we call that class? There we go. Building wall. Well, this is the typical drag it out of the content folder here and just place it in the world, and then snap it to the neighbors, whatever you want to call that. That will make... as you can see when you're looking at the actor, it has these options over here for a door or collision information, structural support, structural support stuff, weak spots where those little pop-ups come to hit in the micro game. All this extra stuff over here, since I don't want this building to be destructible, is extra. Extra means that the server is having to take and think about all these 9,655 actors and consider each actor to say, is it being hit right now? Is it broke? Does it have health problems? All this is sitting on each one of these meshes out here, every actor in the world. Does it allow team damage? Am I currently being damaged by a teammate? Are things that's going on at the server? What we're trying to do when we optimize is say, okay, when does this ever need to be hit and take damage? It never needs to, then we don't want to ever consider it to be hit and take damage. So we're trying to get rid of functionality that we're not going to use, so that functionality is not considered and doesn't provide what's called overhead to make sure every frame that the actor is being considered. So we're trying to take actors, meshes, items, everything out of consideration by any system that we don't need it to be considered by or don't want to use on it, such as damage. Damage is a good one. So when you have your full-on actor here, actors can replicate, actors can cull from the CPU, and all the interaction we've talked about over on the side. The best thing to do is go towards a lighter or the lightest version of that, whatever you need. When you're talking about environment you're just colliding with or doing collisions with, plus you just need to visually see, You can split those two things up, which we will get to. But you can try and focus on just getting the visual there and having just the collision there, rather than all this interaction stuff, like hitting and microgaming and so on being considered for it. A cool way to do that, since you built your level, say like me, you built your level out of a whole bunch of just building pieces that snapped into place. I turned off snapping. I recommend turning off snapping for difficult stuff. But with snapping, and actually, I've spun this building around so it's not on the real grid. So I built one of these, cloned it, and spun them all around. So snapping, once I've built it like that, I turned off snapping when I rotated them so they wouldn't realign. So, you know, showing you how these things snap to each other is not going to work very well right now because they're not on the standard grid. So that's something to keep in mind when you do clone things, is you want to make sure you realign them. You don't have to snap them into place, but you just got to make sure they get aligned on the same spots. Okay, so what you can do with and what this level is built with, is with merged meshes. So let's go ahead and show the merged mesh. So when you're using UEFN props, like the obstacle course here, and also like their trees and their rocks and everything else going on, everything in Fortnite and your custom assets will create a merged mesh HLOD. Now, what is the HLOD world streaming system? We've covered this a little bit in other videos, but let me show it here. Let's see. Put some more zeros. All right. So what we have in the overview here is these white lines. Those are how big my tiles are right now. And my tiles are 25,000 units in size. Now, what happens in each one of these tiles, there's two options really on what you can do in there. You can do what's called a merged mesh. And what a merged mesh does is it takes all of these actors or meshes, these trees, probably not the Niagara system, but I am doing it with these things, these icons over here, so we'll talk about that. But it takes all of the meshes in the triangle, or the big cube, the tile, what they call them, the cell, and it adds them into a single mesh that it generates at that time. Now, I was having issues with how long it takes. I mean, merge mesh takes a long time because it's creating a new mesh. So for each one of these tiles, it will create a new mesh of that size. It will take all of the actors or meshes in there, merge them into a single OBJ or FBX of actual mesh, and try to call that more efficient because it would just be one call for the mesh. Then it makes its own merged texture as well out of the different layers. And that's what when you come in here and you click this default HLOD layer, inside your default HLOD layer, it's asking you, just for the material settings, do we want to take the normal? Do we want to take the tangent? Do we want to take the metallic? Do we want to take the roughness? And these are all new texture data that has to be added into that new generated material and cost you on disk for each cell. So each cell is going to get its own texture and materials to cover the meshes that are in there. And then it will also get its own mesh that's going to be merged of all those vertices at their lowest level of detail. And let's go see that happen. So if we're looking at the blue base here, it's made out of, and let's hide our grids, it's made out of currently blue obstacle actors, just like you would pull out of the content directory. If we go ahead and hide our blue base, it's gone. No more blue base. And if we show all of our HLODs, boop, the blue base is back. Now it's back as a merged mesh HLOD. So if I click on it, I can only select the entire thing. And also the trees around it. Everything in that cell you can see is selected. If I select another cell, you can see there, it's selecting the things that are added to it. If I click up here, I didn't hide these, so I have to go rehide them, but you can see there, I can hide, let's hide everything. Yeah, why not? So we'll hide all the stuff that's not the HLOD. Give you a good view what's going on here. Leave the particles, the billboards are there for the words, green. These are native HLODs. We'll talk about, or native ISMs. We'll talk about that. Orange base, red base, trees and rocks. These trees and rocks get added to instancing. You can see the shadows going away for them there. Bending, sure. White towers, sure. And yeah. All right. So this is not all merged mesh HLODs because these are actually ISMs. You can use both. So on these actors, I selected the instancing type. We'll look at green base. So green base here, if you look at your static mesh component, and you go down to HLOD, you want to make sure it's included in HLOD or else it won't be. And the batching type. So none means it will do a merged mesh. Mesh selection or instancing will make it try and do ISMs or instant static meshes, which will then count as a very light or no cost to you and render much quicker than static meshes, and it's in a competition with batched or with a merged mesh. So merged mesh may render just as fast, meaning your customer might get the same frame rate as using instancing. They're like pretty close. Or merged mesh might even render 1 frame faster when you're talking about, it's such a small difference, but the size on disk. So let's look at the project size. So here we have 11 megs on the level itself, and the shaders are taking up 2 megs. On the ISM version of this project, when we go look at it, the shaders are the far above big one at 2 megs, and the whole level itself only takes like 1 meg. So it's a 10 meg different, at least, in the scene package project size by using merged mesh instead of ISM to get the same result for this level. The more actors you get in there, the more dense that merged mesh becomes, the more it's going to cost, and the more of those cells you have in your world. So the bigger your world is, the more that cost is going to be on your hard drive or on your package size. When using batched or instanced, it does not increase nearly as fast or at all, because it doesn't include any new meshes. It's just saying where are these meshes on the GPU. So it doesn't increase the package size. So the bigger your level is, if you're using merged mesh, the more of your package is going to be that custom mesh that's created for every single cell and takes all the none type of merged HLODs and shoves them into one mesh. All right, we're coming up on 18 minutes. I will split this up. Will I split this up? No, you gotta hang out. I like splitting them up, but let's just get into it. I want to get this done. All right, so we've taken and we've built, and this world you're now seeing, green is a good example, how the merge mesh makes this new mesh here. So this is not a whole bunch of actors making up this building. This is literally like you took the mesh modeling tools and created a new building out of it. It used, I think this one still has, I think green's still on, because this is good, we're close. So you see these little metal pieces right here, they're going to disappear when I turn off green base, because those metal pieces are part of a higher level of detail than what was taken to merge the mesh. So when we get to green base, it is showing. Boom. See, it's gone. We'll do it a few times. Green base has these little extra pieces. And you can see the shadowing's a little better, it looks like, with the non-merged mesh. There's the green base, turn off the HLODs, you can see it doesn't really add anything. But when you take the green base and you turn it on and off, you can see it has those extra details. Because it's taking, when we do our merged mesh, which is what's showing now, it takes the least amount of detail from the actor. And if you make a custom static mesh, which is what we'll talk about next, if you only have one level of detail, then that will force the HLOD system to only take that one level of detail. So that then you could do this and have it be the same exact thing, only ISMs, which is what I'm doing. All right, I'm going to go open up the I guess we will pause the video. So we've been looking at the merged meshed version of the map. We'll go look at the instant static mesh version of the map and then start talking about all the little pieces in the next video. The main thing about the merged mesh, and let me show the level a little bit more here, is that take these away. So what are these? I have native ISM or HISM actors excluded from HLOD. That's what these are. I have these oak trees here, that they are a UEFN mesh. You can go find it. It's right here in Fortnite environment foliage. It is a mesh or a tree that can be instanced. So that means what I did is I made a new actor, and that actor has a HISM component on it right here. So actor class, right under it, the only sub component it has, I went ahead and just said